Hello, I'm Jonathan Cole. Welcome to this educational clip where we will be demonstrating the usage of three measuring instruments. First, we have to inspect our instruments for zero error. Saying that the 0 and 10 marks on the vernier scale coincides with the 0 and 10 marks on the main scale, there is no zero error on the vernier caliper. Seeing that the 0 mark on the timbal scale coincides with the datum line, there is also no zero error on the micrometer screw gauge. We will be measuring all readings 3 times, however, due to time constraints, we will not show us measuring the 3 items 3 times. We will now measure the eraser first. We will use the vernier caliper to measure its length, since it is too long for the micrometer screw gauge. The length is 4.46 centimeters. We will now use the micrometer screw gauge to measure its breadth. The breadth is 9.009 cm. We will now use the micrometer screw gauge to measure its height. The height is 1.0195 cm. Using the formula length times breadth times height equals to volume, the volume of the eraser is an estimated 9.13 centimeters cubed. The mass, as you can see from the electronic balance, is 11.3 grams. Thus, using the formula mass over volume equals to density, the density of the eraser is 1.24 grams per cm cubed. Now, we'll measure the table leg. Using the vernier caliper to measure its internal breadth, the internal breadth is 4.04 centimeters. We'll now turn the table leg to find the internal height, and use the vernier caliper to measure its internal height. The internal height is 4.38 centimeters. We will now slide the meter ruler to find the internal length. To prevent parallax error, we read the reading directly above the meter ruler. The internal length is 26.2 centimeters. We will now measure its external breadth using the vernier caliper, which is 5.04 centimeters. We will now turn the table leg to find the external height. We will now measure its external height using the vernier caliper. We will now measure its external length using the meter ruler, which is 31.2 centimeters. While the internal volume will be an estimated 464 centimeters cubed. Thus, to get its actual volume, we will subtract the internal volume from the external volume, which gives us 329 centimeters cubed. The mass, as you can see, is 235.0 grams. Thus, the density will be 0.71 grams per cm cubed.
We will now use the displacement method to find the volume of the rock. First, placing the Eureka can on a flat surface, we fill the Eureka can with water till it partially covers the opening in the side of the can. Next, placing a dry beaker underneath the spout of the can, we would lower the rock gently into the can, letting the water flow into the beaker until it stops. Bringing our eyes down to be level with the water level so as to prevent parallax error, we read the bottom of the minuscule, which is 37.5 cm cubed.